Good night, Professor. Well, here we are in the final project. Well, finally, I'm gonna have more time than usual. So, all right, let's get to it. Before anything starts, I want to point out a few things that I did not cover in this final project. Just getting it out there right now, forewarning you, and start deducting points because of that. Anyway, let me point it out. So, first of all, you will not be seeing in this project mirrors. I did not complete my mirror from the past homework. It works, not entirely, as you pointed out in the feedback. And honestly, I preferred not to. I just preferred not to have a mirror this time. I had so little time. I'm very sorry. I know. I had crunch time at work this week. I barely even had time. I don't know how this even came through. But anyway, one other thing, I do have a skybox, although it's not a specialized graphic object as you will specify it, or as it's better. It's separate, but has its own shade. Well, not its own shader, but anyway, skybox, I do have it. It works pretty well, although not as its own class. So forewarning you. And finally, it's not a. Where's that one? Oh, I don't have the scene right. Oh, it doesn't say here, I think. Oh, here it is. There must be some attempt at making the scene look aesthetically interesting. Yeah, this is not interesting, although if you like cell shading, which I actually got it to work, might be interesting. Anyway, let's get to it. Before we start, just quick thing, Screencast-O-Matic apparently has two 15-minute parts, so I'm going to focus these 15 minutes, the first ones. I'm going to start explaining my code base by base. I'm going to start with the most basic pre-made models, and I'll show you the basic code, important stuff, and I'll show you the scene. I'll go one by one, and if there's a part 2, I'll let you know about it. Might even put it in the comment section below, in the description box below. Sorry. Anyway, before anything, let me show you what I have on the scene, just so you know. Or at least see what it is. There we go. So we see 2 crates, a magenta light with a soccer ball. This is a custom model. Thank you, Maya. We have a regular sphere with the pre-made models. There is a pyramid. It's another pre-made model. There are only 2, well, technically there are 3 pre-made models. The boxes, the pyramid, and the sphere. I know, it looks... Again, it's boring, but still, bear with me. The whole scene is being rendered with cell shading. So, except, even that guy's supposed to be cell shading, even though it doesn't show. For example, here's a D20 dice. If you ever played Dungeons and Dragons, there are dice with 20 sides. And I decided to have, like a little showcase, this guy rotating slowly with 4 different lights of different colors, so you can see shadows are different. I intended this to be a landing pad for the space frigate, but yeah, it's just a pedestal, I guess. Obviously, the decided, the soccer ball, and the totem that I created, this was supposed to be just a test. That is obviously using Azul models. So, and the whole scene with weird shadowing because I couldn't get the normals working at 100% for the terrain, and obviously fog for everyone except the skybox, as you can see. Alright, now that we've taken a look at the scene, now let's take a look at the code. Let's start with the pre-made models. Alright, so starting with the model class, that's pre-made models anyway. The model class, as we've been working with it since the very beginning of the course, of the quarter, we know that the model class itself holds... oh no, wait, the standard vertex is not part of the model itself. The model obviously has a triangle list, vertices list that every 3D model needs in order to be rendered properly, and all that stuff. The number of vertices, number of triangles. I'm not going to go into much detail. I mean, you made it, by the way. As you can see, the model itself, obviously we have load to data GPU, send all the data to the GPU. We have your function that you made, the load data from file, which I used, you already saw in the scene. Obviously, we have our pre-made models that I'll be taking a look at the model tools, and our 3 constructors, which, first of all, if you already have the models or the vertices, for example, which I made use of in the terrain model, the terrain model makes use of this constructor, which I passed my own vertices, my own numbers, and all that. You know, like, I'll give you the information. The next one, obviously, pre-made models. We've used that hundreds of times in previous homeworks. And again, now the other one with a file path to construct the model itself, you know, a custom 3D model. Anyway, well, that's just about it about the models. Pretty straightforward. In the model tools, again, we have our pre-made models here. I'm gonna go directly to the sphere because I believe that one was the most interesting one that I've made so far. Obviously, a very quick check that I input a minimum of subdivisions, either vertical or horizontal. We have a radius, you know, our lists, creating them, and basically I just set it up. You know, first the very top part of the bottom part in this case, I went from down to up of the sphere, and then I made the entire middle row, and yeah, the entire middle section of the rest of the sphere, and then finally the very... Oh, here they are. Sorry, it's just I made them. I don't know why I made the middle first, right over here. Like, all of this is the middle. Then we have the bottom row, which in this case would be the very first one, and then the very top, the last piece of the sphere. We also have the skybox here. Like, again, I don't have a skybox class, so technically the skybox is just a pre-made model. Let's see here. Yeah, again, it's just, this is a repeated texture cube, except that every face, it's pushed back to their negative, you know, to the other side. So, and their normals still are the same. So, to me, that's just the skybox itself, you know. It's just a pre-made model. I didn't have time to create properly the graphic object class. And finally, model also has now mesh separator in case your 3D model has several meshes, although in this case Azul only holds 4, like the cottage. Or my totem is actually a two mesh one, so you're gonna see about that. Anyway, we have our mesh separator, and that's about it about the models themselves, the model class. Again, here they are, boxes. This is a custom model, the triangle. This is another custom model. This is a custom model too. This one right here, the pedestal or landing path. And here's the totem that I switched colors. You know, just to better show that I am actually using the mesh separator and all that, and also the sphere. All right, let's get to the next checkpoint, which is the skybox. Let me load that. All right, so the skybox obviously has its own matrix. We don't need that. It has a very simple shader color shader, which means no lights, no fog. That's it. And texture in this case. It only takes a texture. So, again, I didn't have time to polish it or have a fancy skybox. Sorry. Anyway, we have the model itself. It's a pre-made model called Unit Skybox, which is just a repeated texture cube with inverted, well, not inverted technically. It's just a different kind of cube. And obviously, as you can see, I've scaled it like to 1,000. It's hugely scaled. I don't know if this is the right way to do a skybox. I mean, I did it this way, so and that's it. You know, that's just it. And obviously down here in draw scene, the very, very, very first thing that I do is or should I say the very last thing, actually? Yeah, it's actually the very last thing. I'm sorry. I render the skybox at the very end, you know, setting the context to its respective shader, which is just a simple color shader with a texture with no lights and fog, as I said. We have, oh, wait a minute, I'm using a graphic object. Huh. Sorry about that, I didn't remember. Like I said, I've had a busy week. Oh, look, so I do make use of oh, here we go. So, I created a graphic object called unlit model, which is just perfect for the skybox. So, it's a graphic object called graphic object unlit model, or Go unlit model is just shorter. I pass in the text. Oh no, sorry. I pass in the shader. I pass in the model, and then I pass in the texture, and I just set it to a white color. So that's my skybox. I know it's not its own class. It should be its own class, but hey, at least it's a graphic object, right? All right. Next in the checklist is the terrain model itself. For the terrain model, I decided to fuse it, the model class as in a graphic object, whereas basically my Azul terrain, sorry for the original name, I take in a normal cell shader with color. In this case, obviously it won't take a texture. I didn't figure out the repeated UV for the terrain. Sorry about that. Yeah, okay, so start deducting points over there. So yeah, no texture on the terrain. But it takes in the shader, it takes in a model, it has a matrix, and it has a color. So basically, it is a graphic object. My Azul terrain class is a graphic object, except that it's specifically designed to have terrains. I don't have a default constructor. I just simply pass in the device, the height map file that we were going to be used to read it, and finally the cell shader color. Excuse me. The cell shader, then in this case it'll be using the colored one, no texture at this moment. Again, sorry. And we pass in simply color, we pass in the world, and finally a very simple render function. Pretty straightforward. The constructor, obviously, we assert that we do have a shader. We keep the shader, we keep a reference to that shader. We get a scratch image, we load the TGA file to DirectX, make sure everything went well. And finally, we read it as an image itself, not as a scratch image. A height map, make sure that in this case the size is the same. We could obviously go, my code is already, it's ready for a rectangle in this case, for example. And then this is where, in my opinion, everything goes awesome. Oh, okay, sorry. Everything goes good. We have the integers, height and width. You know, we have integers so we can use it to create our own terrain. Our lists as always, and finally create a plane starting from height 0. I go in rows, you know, starting from the very top to the bottom, and always start from top, then go left to right, and then next row. You know, like a typewriter. You know, start typing in and then ding, and you know, repeat, rinse and repeat. That's the way I do it. So start from 0. Again, start from 0 and to make our magic work, depending on the value from 0 to 225 of the height map, which has to be from black to white. We take the value, and then oh yeah, this print is just to make sure if I ever had whites. And all I do is just, you know, divide it by 255 and multiply it by 10 so that we don't have so exaggerated terrains. Like seriously, they were overly exaggerated the first time. We have our triangle lists, which in this case we always take, you know, I go in this case by squares, so it would be triangle 1 and then triangle 2 would be the right below in the same square. That's how I go. You know, that's just how I did it. And finally for the normals, I just, it's a big mess, but all I do is I try to take the cross product between the triangles that vertice touches, or belongs to in this case, add all the cross products and have it multiplied by the average in this case. If they were 3 vectors, resulting vectors, I sum all 3 of them and multiply them by 0.33, I think it was. And that's it. You know, again, it's not that bad for a terrain with models. Again, I don't think it's that bad, especially for a cell shader, which the shadows are always that wonky or terrible. Anyway, I'm going to stop the video because Screencast-O-Matic is about to kick me out. I'm going to upload this, and I'll see you in part 2.